Okay. Even if suppose you don't remember alternate way, we have already got the current when the deflection is full scale. What will be the voltage when the deflection is full scale?
So 75 millivolts.
75. 75. Two division responds to 1 millivolt.
So is it 5 ohm? Is it 5 ohm?
Corresponds to 75 millivolts. So when current is corresponding to full scale deflection current is 15 milliampere and the voltage is 75. Voltage divided by current will be the resistance of galvanometer. So total voltage divided by total current. V by Ig minus Rg. V is 150 volt that we want. Ig we have figured out from the current sensitivity and galvanometer resistance come out 75 millivolt by 15 milliampere. 5. Information will not be directly given, that we have to figure out from the data. Like in this case, current sensitivity and voltage sensitivity is given.
So what I did was I found कि one division से कितना current चाहिए होता है for one division to go on, and in one division how much voltage is required. Then I divided that and I got the same result.
It also give the same.
I got the same result. So instead of using full scale by full scale, I did one division by one division, and I got the same result.
Right. That's the same thing, by the way. Because the divisions are directly proportional to the current passing through it. And it is also proportional to the voltage applied across it. If there are 50 division and one division is 1 microampere or milliampere, likewise it will be the same. So kind of it is the same thing. You can use the full scale or you can use one, but full scale is like more convenient to think. Exam full scale means full current, full voltage. Because anyway this information we have to use for solving the series resistance. Ig is one requirement. Ig is deflection current, full deflection current. Rg is the resistance of galvanometer. By using these two values, we can find out shunt required and we can find the series resistance required. This is voltmeter. In voltmeter, we connected in series. So Rg plus Rs. 150 divided by 15 milliampere minus 5. The resistance should be connected in series. Yes. What is the answer? Yes, what is the answer? Second option?
Second option.
9995. So this is a question which is very straightforward, similar, but directly information of current, full scale current and full deflection. Resistance is not given, but yes, we can find out by using the information, the data. Next question is question number 11. The scale of a galvanometer of resistance 100 ohm contains 25 division. It gives a reflection of 1 division on passing current of 4 into 10 to the power minus 4. So galvanometer resistance is given as 100 ohm. I'm talking about question number 11. You don't have to solve, just read the question, figure out that all the information is actually given. Question number 11, the total resistance of galvanometer is 100 ohm. 1 division correspond to 4 into 10 to the power minus 4 ampere multiplied by 25. That will be the full deflection current. Again, we will apply the same formula for finding the series resistance required to convert it into voltage. So this is for converting the galvanometer into a meter and voltmeter. Next is question number 14. It's also a previous exam question. Question number 14, 1-4. To increase the current sensitivity of a moving coil galvanometer by 50%, its resistance is increased so that the new resistance is twice of the initial resistance. Voltage sensitivity changes by. Question number 14 from the same DPP. Says that to increase the current sensitivity of moving coil galvanometer by 50%. So whatever is the initial intensity, now we are making it 1.5 times. Resistance is increased so that the new resistance is twice the initial resistance, then its voltage sensitivity changes are. This was the relation between voltage sensitivity and current sensitivity. Voltage sensitivity is current sensitivity divided by resistance, right? And that's why voltage sensitivity cannot be increased by increasing number of turns, because N and R both are proportional. They will increase in the same ratio. It says that current sensitivity has to be increased by 50%, so it becomes current sensitivity. Current sensitivity is increased by 50%, resistance is doubled. What happens to the voltage sensitivity then? Voltage sensitivity becomes 3 by 4. So what is the answer?
Decreased by 1 by 4.
Decreased by a factor of 1 by 4. So it has decreased by 1 by 4 times. S becomes 3 by 4 times SV. So question was direct formula based, but language you need to understand. Current sensitivity is voltage sensitivity into R. Current sensitivity में NAB by K was the formula, and voltage sensitivity NAB by K times R. Voltage sensitivity remains same even on increasing the number of turns, because the ratio of number of turns and resistance is next. So I'm going also on the back DPP number 6 make some questions we have done. One last question is question number 20. A microammeter has a resistance of 100 ohm and full scale range of 50 microampere. What is microammeter? What is a microammeter?
It measures current in microamps.
Very intelligent. Okay. Vyom, what is microammeter? Vyom? Microammeter means? Vyom?
So is it the screw?
Yes, sir.
Yes, someone said something. Yes, Vyom. Microammeter क्या होता है बेटा? Microammeter is what?
Sir, screw gauge.
वो micrometer था. That was micrometer. This is micrometer. Micrometer is another name for galvanometer. Why? Because if the current is already in the microampere range, current will be almost detected accurately by a galvanometer because already its resistance is so high. उसमें थोड़ा बहुत galvanometer का resistance include भी हो जाता है when it is connected in series. It will not have much change, so that's why the microampere range की current को हम measure कर सकते हैं with the help of galvanometer. Hence it is termed as micrometer. Micrometer मतलब इसमें current micro ampere के range पे हो, and that can be galvanometer. There is no need to connect shunt or anything because the current is already in the microampere range. Now it says it has a resistance of 100 ohm and full scale range of 50 microampere. Galvanometer resistance is 100 ohm and full scale current is 50 microampere. How can we convert this into a higher range? It can be used as a voltmeter and as a higher range emitter provided a resistance. So it's a multiple choice. You have to check. Series में लगाने पे voltmeter बनता है, parallel में लगाने पे ammeter बनता है. You can check which of the option is correct. Which two options are correct? Yes. Proof.
So,
How are you बेटा? बहुत टाइम के बाद क्लास अटेंड किया आपने शायद. हमारी क्लासें नहीं हो पाती हैं वीकेंड में, 2-3 बार से तो छुट्टी हो रही है.
लास्ट क्लास में तो था मैं.
अच्छा, लास्ट क्लास में थे. ओके फाइन. यस, लास्ट क्लास में कुछ समझ में आया था? दैट टॉर्क एंड ऑल.
से रिवाइज करना है बस एक बार वो. अभी यार मेरे को टाइम नहीं मिल रहा थोड़ा रिवाइज करने का स्कूल के थोड़े असाइनमेंट्स में.
Conversion of galvanometer into ammeter and voltmeter. This topic we did. इसमें किसी को डाउट है?
सर एमसीक्यू वाले में.
हाँ बेटा.
सर एमसीक्यू वाले की कर रहे हो?
बेटा मैं पूछता हूँ, ये जो हमने टॉपिक किया था कन्वर्जन ऑफ गैल्वेनोमीटर इनटू अमीटर एंड वोल्टमीटर, दैट टॉपिक इज क्लियर ना? उसमें कोई डाउट तो नहीं है? स्पेशली दी वीकेंड बैच. चलो हम वापस आते हैं. वी विल सी इन द वीकेंड क्लास. अगर डाउट होगा तो फिर से पढ़ लेंगे. कम टू डीपीपी नंबर 5. डीपीपी नंबर 5. All of you have in the group magnetic dipole and magnetic dipole moment and the torque acting on it. All of you have this DPP number 5.
Yes, sir.
Magnetic dipole moment and torque. Krish?
Yes, sir.
DPP number 5. You are attending in weekend batch, na? Yeah, I said in the group. चलो हम questions करते start. Question number.
सर ऑफलाइन आया कोई?
ऑफलाइन बेटा आज तो कोई नहीं आया. वीकडेज वाले बैच के बच्चे आए. मंडे वेडनेसडे फ्राइडे वाले बच्चे हैं करीब 5-6 बच्चे 4 PM वाली क्लास में. बट इस वाली क्लास में तो कोई नहीं आया. You are most welcome from next day.
सर मैं
DPP
संडे
number
को
5.
आऊंगा.
Question number. DPP number 5. Question number 4. A current carrying ring with its center at origin has a magnetic moment of. DPP number 5. Question number 4. A current carrying ring with its center at origin has a magnetic moment of 4I minus 3J. 4i cap minus 3j cap ampere into meter square. That's dipole moment. It time t is equal to 0. A magnetic field of 3i plus 4j. This magnetic field is switched on at time t is equal to 0. Calculate the initial torque and calculate the potential energy of the loop at time t is equal to 0. Yes. Calculate the torque at time t is equal to 0 and calculate the potential energy at time t is equal to 0. टॉर्क का फॉर्मूला क्या होता है भरत? टॉर्क ऑन ए मैग्नेटिक डाइपोल.
Torque on magnetic dipole.
Yes.
Sir,
देखना पड़ेगा पीछे ना.
Ni cross AB.
In the vector form m cross b, m is equal to nia, so we can use this nia. nia की जरूरत क्या नहीं है क्योंकि यहाँ पे डायरेक्ट डाइपोल मोमेंट वेक्टर गिवन है. So we'll calculate the cross product of m and b. Cross product के लिए we can use the determinant method. 4 minus 3 0. So we can calculate. K cap is not required here because that's fine. Cross multiply कर लेते हैं. Leave that row and that column to 0 0. ऐसा कितना होगा? J को कम कॉमन कर लेते हैं तो 4 into 0 0 0 only K cap
25 K cap.
16 minus of minus 9, so that's 25 K cap. What about potential energy formula? Potential energy का क्या था? Potential energy formula for a dipole in external magnetic field is Aradhya. We have the VPBs. Aradhya. What is the potential energy? What is the potential energy coming out to be? Yes. 0. 0. M dot B. Potential energy will be 0. क्या मुझे आवाज नहीं आ
जीरो
रही?
कैसे सर?
डॉट प्रोडक्ट करो 4 into 3 12 minus 3 into 4 minus 12 12 minus 12 0.
ओके सर.
डॉट प्रोडक्ट कैसे करते हैं? आई को आई से जे को जे से then we added स्केलर प्रोडक्ट का फॉर्मूला माइनस एम बी कॉस थीटा और माइनस एम डॉट बी. क्वेश्चन नंबर 5 6 7 सारे कर लेते हैं लाइन से. क्वेश्चन नंबर 5. A loop carrying current I lies in the xy plane as shown in the figure. The unit vector k cap is coming out of the plane. Find the magnetic moment of the current loop. तो loop कैसा है? For any current carrying loop, its magnetic moment is Ni into A vector. A is the area vector. ये दीदी भी किया है किसी ने होमवर्क में? मतलब
No, sir.
only the moving parameter one. The 4 semicircles बीच में सेंटर पे एक स्क्वायर अज्यूम कर लेते हैं. साइड लेंथ ए का. We have to calculate n तो एक ही I into area vector. एरिया किसका? अंदर के स्क्वायर का और ये चारों से. So when you add them, it becomes 2 pi r square. Current I बीच में स्क्वायर है, उसका एरिया ए स्क्वायर और बाहर के चारों सर्कल को सेमी सर्कल को ऐड कर दोगे तो ये it will become equal to 2 circles. 2 pi square.
A by 2 square.
A is diameter, A by 2 square. Okay, cap. E plus current is anti-clockwise. Current की direction में we curl it, so it is coming out of the plane. Very good. Question number 6. The figure represent 4 position of a current carrying coil in magnetic field directed towards right. N cap represent the direction of area vector. Calculate the current order. The correct order of potential energy. Question number 6. इसका आंसर क्या हुआ? फिफ्थ का फिर इसका आंसर D. It's not D, it's B. Pi by 2 plus 1 A square I. Question number 6. Question number 6 says the figure represents the 4 position of current carrying coil. N cap represent the direction of dipole moment vector. Second one is vertically downwards. तीसरा angle theta पे. Fish. Arrange them in increasing order of potential energy. Yes. Mr. Krish, potential energy का formula भी पीछे लिख चुके हैं. U is equal to minus mb cos theta. So accordingly, you have to decide which is at the lowest energy. Which is at lowest energy? पहले में theta कितना है? Theta is
180.
180. So it will be minus 1 because cos 30 is minus 1. Minus 1 has become. So in fact, this is maximum. First is maximum. Cos 180 की minimum value, cos sigma value minus 1 हो सकती है. Minus minus plus. So 1 is the highest. अब आते हैं हम out of the second one. Theta is 90. Theta 90. So potential energy will be 0. It will be 0. Now we'll have to see. ये तो positive है. 0. Out of 3 and 4. In number third, the angle is greater than 90, so it is going to be negative. In number 4, the angle between them is acute angle less than 90, so it is going to be positive. So first one is maximum positive, then fourth, it is small but positive, then second, it is 0, and in the case of third, it is going to be negative.
थर्ड ज्यादा बड़ा होगा.
Third and then.
थर्ड नेगेटिव होगा नहीं.
Third will be positive. Fourth will be negative because it minus sign है ना.
नेगेटिव.
ये minus mb cos theta. Theta is 180. Cos 180 is minus 1. So this becomes plus mb. This becomes 0. This becomes plus mb, but somewhere because यहाँ पे cos theta is greater than 90 degree. Cos theta की value negative आएगी. Negative will become positive. That is why third positive is greater than 0. Fourth वाले में angle is less than 90, so cos will be positive but potential energy will be negative, which is first option A. Option number A. Potential energy में आपको minus sign पे ध्यान देना है because there is a minus sign also. So if angle theta is less than 90, that will be positive, but with a minus sign that become negative. So least value is 4, maximum value is of first answer will be A. Number 7. A conducting ring of mass 2 kg and radius 0.5 is placed on a smooth horizontal plane. Ring carries a current I is equal to 4 ampere. Horizontal magnetic field B is equal to 10 Tesla is switch time B is equal to 0. The initial angular acceleration of the ring. Okay. Question number 7 में magnetic dipole moment calculate करेंगे. Magnetic field is given. They both are perpendicular to each other. Torque is mb sin theta. Theta is 90 degree. That torque will be equal to I times. Talking about question number 7. Question number 7 is conducting ring of mass 2 kg. What is the moment of inertia for a ring? Formula for moment of inertia of a ring. Moment of inertia of a ring.
IR square by 2.
Huh?
Sir, MR square by 2.
Yeah, so British चल रहा है क्या चल रहा है? Google. Socrates.
नहीं सर याद है ये तो.
MR square गलत बता रहे हो इसलिए पूछ रहा हूँ. अगर क्वेश्चन पूछते हैं what is the moment of inertia, it is an incomplete question unless the axis is not specified. तो हमें पहले axis बतानी चाहिए. Axis कहाँ पर है? Assuming that axis is passing through center, क्योंकि ये center के about rotate होगा, then it is called that is MR square.
सर इतना याद नहीं है अब.
MR square by 2 कैसे है बेटा बताओगे?
सर तुक्का लगाया.
हाँ? Conducting ring of mass m and radius 0.5 is placed on a smooth horizontal plane. The ring carries a current I. Horizontal magnetic field, the initial angular acceleration of the ring. रिंग के लिए इट इज what
Yes,
is the
sir.
direction of what is the direction of torque?
सर क्या फॉर्मूला है?
आपने पहले समझो सिचुएशन है कि दिस इज द रिंग, दिस इज द रिंग which is placed in a magnetic field. अब I mr स्क्वायर होता है about the axis passing through the center perpendicularly. तो ये इसके about रोटेट हो रहा है या कैसे रोटेट हो रहा है, then only we can apply that formula. ये तो पता है कि हमें टॉर्क निकालना है, टॉर्क इज इक्वल टू I टाइम्स अल्फा. But torque is about which axis? उसी एक्सिस के अबाउट हमें मोमेंट ऑफ इनर्शिया भी चाहिए. क्वेश्चन सॉल्व करना इजी है, बट क्वेश्चन की एनालिसिस करनी पड़ती है हमें. हाउ वी गॉट दैट रिजल्ट. आंसर माय क्वेश्चन अबाउट which axis this torque is acting. X axis, Y axis or Z axis?
सर एक्स.
So y-axis.
Okay, I'll just find out the axis also. मोमेंट ऑफ इनर्शिया अलग अलग एक्सिस के अबाउट अलग होता है. Z एक्सिस के अबाउट mr स्क्वायर, x और y डायमीटर बन जाएगी तो mr स्क्वायर बाय 2. द क्वेश्चन इज whether it is rotating like this is about the Z axis, or it is rotating like this is about the Y axis, or if it is rotating about X axis, that will be like this. So when you analyze the question, you have to analyze the complete direction also. कैसे पता कर सकते हैं? हवा में तो पता नहीं पड़ेगा. So we will find out the direction of force. Find the direction of force on the opposite end. So पहले नीचे की तरफ जा रही है magnetic field right side में. What is the direction of force on this magnetic field? नीचे. I'm just coming out of the plane. I'm just coming out of the. If you go on the opposite end, magnetic field current ऊपर की तरफ, thumb is going inside. As a result, now we can see that the torque of each couple or each pair is not rotating this along the Z axis, it will be rotating about the Y axis. Correct? If it
Yes,
is
sir.
rotating about the Y axis, इसके about torque और हमें इसी का moment of inertia चाहिए. रिंग का उसके सेंटर से पास होने वाली परपेंडिकुलर एक्सिस के अबाउट mr स्क्वायर, और रिंग का उसके डायमीटर के अबाउट mr स्क्वायर बाय 2 by using that perpendicular axis. Torque is mv sin theta and is I pi r square into b. Theta इस टाइम पे 90 डिग्री है because magnetic dipole moment is inside and dipole and magnetic field is into the plane. Moment of inertia mr square होता अगर ये ऐसे रोटेट होती, but now it is rotating about the diameter axis, mr square by 2. So में alpha की value. So thus if a question is asked what is the moment of inertia, it cannot specify जब तक कि हमें axis of rotation नहीं.
सर सही तुक्का था मतलब.
Yes. Next question number 9. A rectangular coil PQ. Question number 8 हम कर चुके हैं, इसलिए question 8 is in the notebook. Question number 9. A rectangular coil PQ has 2 n turns, area 2A, and carries the current 2I. As shown, the plane of coil is 60 degree. इसमें सिर्फ इतना सा डिफरेंस है, प्लेन अगर 60 डिग्री पे होता है तो डायपोल मोमेंट विल बी at 30 degrees. So instead of theta 60, we should use theta as 30 degrees.
So can you explain that कि वो plane 60 पे कैसे होगा?
This is the plane having some number of turns. The direction of magnetic dipole moment is always perpendicular to the plane. Current की डायरेक्शन में फिंगर कर्व करेंगे, thumb is coming perpendicular to this. Plane is at an angle of 60 degrees, so dipole moment is at an angle of
30.
30 degrees. So m is equal to mb into sin theta. थीटा में हम साइन में थीटा को 30 लेंगे या फिर cos में 60 ले सकते हैं. Sin 30 and cos 60 is same, so it will be second option, option number B. Question number 10. Especially mostly the question have been asked in the JEE and other exams. That's why we are solving some of the questions together. So one single correct answer है, वो सारे के सारे important है for even NEET and now even for the poll. More than one maybe not that important now. Question number 10 for the boards only. For the computer level, yes, it's very important. The more than one is the trickiest one. Figure shows a square current carrying loop ABCD of side 10 centimeter and current 10 ampere. The magnetic moment. Question number 10. So there is a square loop and that is inclined at an angle 30 degree with the XY plane. I am not drawing the Z plane because that becomes confusing. For the understanding, I'm just showing this. This is XY plane, outward is Z plane. The plane is inclined with XY at an angle of 30 degree, like this. This is the plane which is inclined at an angle 30 degree with the XY plane. This angle is given as 30. So when we see from the side, when we see from the top, we'll be able to see only this number. A, B, C, if we name the last point as B, we are able to see only A क्योंकि हम उसको Z axis की तरफ से देख रहे हैं. This is the position from where we are looking at it. This is the position from where we are looking at. So we are only able to see A, and that is making an angle of 30 degree with the X axis. In fact, with the XY plane. Z axis मैंने जानबूझ के नहीं बनाई है क्योंकि 3D में this diagram is not very clear. The plane is kept perpendicular to this. Z axis is outward. जब हम इसको साइड से देख रहे हैं तो हमें केवल इसकी एक लेंथ दिखेगी D to A which carries current of 10 ampere. Magnetic dipole moment is always perpendicular to it. Perpendicular to this will be the dipole moment. हमें इसको एक्सप्रेस करना है वेक्टोरली, so we will resolve this. 30, 90, 60, 30, and this becomes 60. M को अब हम दो कंपोनेंट में डिवाइड कर लेते हैं, M cos 60 and M sin 60. This magnetic dipole moment in vector form m cos 60 I cap minus m sin 60, where m is equal to ni into a, m is equal to ni. Question number 10. When this is kept in some magnetic field, अगर torque निकालना होगा, then torque will be m cross b. Okay, question number 10 का diagram आ गया समझ?
Yes, sir.
Plane was at an angle 30 degree with the xy plane, which is not very clear in the diagram if we show the z-axis. So we didn't show the z-axis. That is coming out of the plane, and the plane is kept perpendicular to xy like this. This plane का x is the साथ angle 30 degree है. We draw the perpendicular, which is the dipole moment direction. Dipole moment is resolved into two perpendicular components, and then we will write the vector as m cos 60 I cap plus m sin 60 j cap, where m is the dipole moment vector. Correct?
Yes, sir.
Yes.
Question number 11 and 12 is थोड़े से अच्छे. Then there was maybe till 13 we will do, and then we'll go back to number 4. Meanwhile, if you have any doubt, you can send it in the group.
So can you show the working for question 10?
And further, I should solve.
Yes, sir.
Final answer. Okay, current is 10, side length is 10 centimeter. There's only one loop. 10 into 0.1 square, so that will be 0.1. The side length is 10 centimeters, so square करेंगे it will be 0.01 multiplied by 10, that's 0.1. Right? 0.1 or 60 1 by 2 sin 60 is root 3 by 2. 0.1 by 2 is 0.05. We take both sides common. I cap minus root 3j cap, that's A option. Correct?
Yes, sir.
Question number 9. Meher.
So he's not on the meet.
I think he was the first one to join. Okay. 16 से 13 हो गया, 3 लोग शायद. Okay. He may be one of them. No problem. Question number 12. Sorry, question number 11. A uniform conducting rectangular loop of side L, length L, breadth B, and mass M, carrying current I is hanging horizontally with the help of two vertical strings. There exists a uniform horizontal magnetic field B, which is parallel to the longer side of the loop. The value of tension which is least is. Okay. Very nice. So there are two vertical tension strings which have tension, but obviously the tension is not same because there is an additional torque added by the magnetic field. The magnetic field provides one more torque. Because of that torque, one of the tension has to be increased in magnitude. About the center we are talking, so First important step is to draw the correct field, showing all the forces in correct direction. So ये एक rectangular loop है which carries current. Again like this. Initially it is hanging from both the sides by two wires. Like this. When there is no other torque in the center पे लगेगा, दोनों तरफ के T and D will be equal because their torque also needs to be balanced. But when there is a current passing into it and there is a magnetic field, now the torque will not be same, torque will be different. One side torque has to be greater than another. Horizontal direction is magnetic field, so there will be some magnetic field torque also. So the tension which is least current is not shown, so maybe you can just assume force will be on these two wires 0, on this wire magnetic field current is coming out of इसमें force ऊपर की तरफ होगा and here the force will be downward. So about the center there will be a torque which is provided by the magnetic field like this. T2 का torque और उसमें magnetic field का torque both will be added. T2 into L by 2 minus T1 into L by 2 will be equal to torque due to the magnetic field which is MB. M is ILB. I into area into B. Initial angle is 90 और दूसरी रिलेशन आएगा that is T1 plus T2 is equal to M. T2 minus T1 will be 2 times IB. We'll solve these two equations. Subtract कर दोगे तो mg minus 2 IB into B divided by 2. I think one will be mg minus, another will be mg plus. Understood this situation? Tension पहले equal था जब तक magnetic field का torque नहीं आया because of the magnetic field torque. Now one side torque has to be greater, which is T1. T1 torque has become greater, and the other side T2 torque. So their resultant will be balancing the torque due to center के about हमने torque balance किया है. This equation obviously we have to specify. So this is torque balance about 0.4. Solve T1 and T2 and we get one option as mg minus 12, another option as mg plus 12. Right? Okay. Question number 13. 13 is okay. 12. For the figure, a coil of single term is bound on the sphere of radius r and mass m. The plane of coil is parallel to the inclined plane, is lying in the equatorial plane of the sphere, and the sphere in rotational equilibrium. Then the value of. ठीक है. Question number 11 understood. बेटा अपने डाउट्स भेज दिया करो फ्राइडे को पहले, तो हम पहले वो कर लिया करें. These are slightly challenging ones, but yes, our goal is to cover the JEE level and the computer level also. Question number 12, last question में check कर लेते हैं. There is a magnetic field torque that is mp sin theta. There is a gravity torque, and those two torque are balancing out each other. Okay, so I think we can continue next time. 12 and 13 is on the similar logic as question number 11. 13 में तो formula आएगा, work done formula is mv into cos theta 1 minus cos theta 2. So magnetic dipole, इसके पहले dpp 4 and 3, that is on magnetic force on current carrying wire, magnetic force. So Ampere's law, I think Ampere's law and VAIBHAV law we kind of discussed some of the questions we did in class. So next class we will start the magnetism. In the weekend batch, I think some portion is left, so that will be covered tomorrow. Okay, thank you.